We're back to online. Okay, now it's 24th on. I think still some people need to join. Good morning, Ushka. Good morning, everyone. So hope all of you revised the free body diagram of the objects. Okay. So on the free body diagram, I think revised are important. So let us see some of other situations also. In some situations, free body diagram project now. Then we go for different concepts. Okay. See, you have to revise from here like anything. Because from here, what they say that physics will get so many applications. So application of the what the subject will increase. Okay. So you have to practice a lot. Okay, no? Yeah. So these are the some situations. Yesterday we had done the free body diagram. So total we are trying to identify 3 different forces. Am I right? We are working with the 3 forces only. One is what? One is gravity, no weight. One is weight. The second one is normal reaction. Normal reaction will act when objects are in contact, when surfaces are in contact. When object is kept on the surface, then normal reaction will act. Okay, no? And what is the next force is? Third force is tension. So when tension will act, so tension will act along the strings. Along the strings, tension will act. Okay. Along the strings, tension will act. So according to the given situation, you need to understand. If contacts are there, normal reaction will act. If strings are there, tension will act. Weight anyway will act. When you are taking the object, weight will be there. So weight is compulsory force you can take. Okay. Yeah. So these are the some examples we have done. So this is the last example we have done. So F is the external force acting from the outside. There are 2 objects M1 and M2 in contact. Now we are applying the force on M1. We are pushing the M1. Then M1 will push the M2. M1 will apply the force on M2. So that force I am writing as small f. So small f we are naming it as what? It's a normal force only. It's a normal force or normal reaction, but we are naming it as it's a contact force. Okay, that normal force only we are writing as contact force between M1 and M2. So from the ground, normal reaction will act, which is N1 on M1. On M2, N2 will act. Okay, so F is the force acting on M2 by M1. Even same force will act on M1 by M2 also, action reaction rate. Okay, if M1 is applying the force on M2, M2 also will apply the force on M1. Action reaction rate. Okay. So then what happens? On M1, you will get another around 4 forces acting. On M2, 3 forces are acting. Okay. So same situation, that is increase the number of objects. Let us go with 3 objects now. All of you try for these 3 objects. Let us say this is M1, is in contact with M2, is in contact with M3, and let us say F is the force acting. This is the ground. The ground is smooth, so no roughness or no friction. Okay, entire friction we are going to discuss in the next chapter. So all of you draw the free body diagram for the M1, M2, and M3. Nikhil, at the end of the class, you ask me. Okay? Momentum you have to derive only in that question. You have to derive and you have to find out the force. Okay, I'll explain at the end of the class. Okay, we are pushing the M1, then M1 will apply the force and M1 will push the you can go on your own. No problem. Okay, I think now it's okay, right? I think all of you are able to hear me clearly. Okay. So as we are pushing the M1, then M1 will push the M2 with F1 force. We can name it differently also. So naming is our choice. M2 will push the M3 with F3 force. So F2 force will be ready. Understood? I drawn the first all pushing forces. We are pushing the M1 with F force. M1 will push the M2 with F2 F1 force. M2 will push the F3 with F2 force. All of you okay? Varshita okay na? Pavitra and Varshita, are you able to hear me or not? Okay. So as M1 is applying the force on M2, M2 also will apply the force, same force, but in opposite direction, F1. As M2 is applying the force on M3, M3 will apply the force on M2 in backward direction. Okay, Pavitra. Then what will be the free body diagram for each object? Let us say if I take M1 object, then F is the force acting and F1 is the force acting backward, right? Then M1G, gravity will act downward, and from the ground normal direction N1 is acting upward. So these are the forces acting on M1. Okay. Then what are the forces acting on M2? On M2, what will be the forces? F1 will be the force acting. M1 will try to push the M2 with F1 force, and M2G will act downward, and normal direction will act upward. And there is one more force, that is F2, which is applied by the M3. It's something like a sandwich. Pavitra, On M2, four forces are acting. On M1 and M2, four forces will act. Okay, F1, F2 will be the forces acting on M2. On M2, M1 will apply the force, even M3 also will apply the force. Okay, na? Next, on M3, what are the force acting? On M3, F2 is the force acting by M2, and M3G, weight will act downward, and M3, normal direction will act upward. Okay, na? These are the forces acting on individual blocks. Where is Gautam? Chemistry completed, huh? Okay. Okay. So all of you completed. In similar way, I'm going to give one more example related to strings. There is a block of mass M1. Now it is connected by a string. Okay, inextensible string means length of the string does not change on application of the force. Okay, na? So usually strings are massless and inextensible. What are strings we are taking? String is massless and inextensible, means length of the string does not change on application of force. So now I'm taking the two blocks M1 and M2 which are connected by a string, and we are applying the force F and we are pulling them. Now we are pulling them, or we are pulling the forces, sorry, pulling the blocks with the force of F. Now draw the free body diagram on M1 and M2. Okay. So what is the difference between above situation and below situation? In above situation, objects are in contact. So there is a normal force or contact force act between the objects. But in the below situation, now objects are connected by a string. Then what type of forces will act on the objects? Okay, so as strings are there, what force will include? Tension force will include. Okay. Okay. Okay, Nikhil and Pavitra. Draw the diagram clearly. Okay. If you are able to draw the free body diagram, then half of the questions of Newton's motion are finished. Even you can learn mechanics also very well. That's why I'm giving each and every situation. Okay. All the situations I'm giving, so that the next journey will be smoother after Newton's motion. So next friction is there. Again, you have to draw the free body diagram. So in the rough surface, friction force also you have to draw. You have to draw one more force, friction force. Next, work per energy. You have to find out the work done by forces. Means you have to know the forces. So like that. So if you can, understand this fundamental. So remaining things, at least you can go ahead easily. Okay, drawn. So as strings are given, how the tension forces will act. Tension will act always away from the object along the string. On M1, how the tension will act? Tension will act away from the M1, okay, along the string. On M2, how the tension will act? Away from the M2 and along the string. So tension force will act always away from the objects and along the string. And as string is massless and inextensible, then the equal tension forces will act throughout the string. The string A point is tension value same is. Other string mass in the tension value will differ. Okay. Now if I draw first on M1 block, okay, free body diagram, then tension will act forward, M1G will act downward, normal direction will act upward, alright, N1 and M1G, and tension is acting forward. Because of this tension only M1 will move. M2 will move because of the F force. As M2 moves, M1 also will move because of tension. Okay. So similarly, if I draw the free body diagram on M2, if I draw the free body diagram, then F is the force acting forward. You have to write down all the forces which are acting on the object. Then tension will act backward. M2G is the weight. Normal direction is M. M2 is the normal direction. Clear? How many of you drawn correctly? Okay. It open. Okay. So most of the people drawn. Very good. Nice. Glory is not there. Glory nowadays is not answering. Chandana, one thing correct. Okay, verify the other one. Today A mistake or A force mistake or Glory or there. So Glory, why you are not answering nowadays? Samira, you drawn which is the Katika Charity process? Okay. Vaishnavi, need to? Vaishnavi, draw the Saman rule. Okay. So I think all of you understood. If strings are there, how to draw the tensions. Okay, Kanishka. Check. wrong అంటే తప్పుగా డ్రా చేసా ఫోర్సెస్. ఓకే, లీవింగ్ ద ఫోర్స్ ఇస్ ఓకే. మీరు ఫోర్స్ డ్రా చేయకుండా ఉన్నారనుకోండి, దట్ ఈస్ యాక్సెప్టబుల్ మిస్టేక్. అదే మీరు ఫోర్స్ తప్పుగా డ్రా చేశారనుకోండి, దట్ మీన్స్ యూ హావ్ టు వెరిఫై యువర్ అండర్స్టాండింగ్ మార్క్స్. ఓకేనా, చెక్ చేసుకోండి, తప్పులు చేయకూడదు ఫస్ట్ ఆఫ్ ఆల్. Yeah, so these are the some things we have done with the free body diagram. So మన ఏ సిచ్యువేషన్ ఇచ్చినా ఫ్రీ బాడీ డయాగ్రామ్ డ్రా చేసే విధంగా ఉండాలి. ఓకేనా. సో the first important concept of Newton's law of motion is equilibrium of objects. Now we are discussing equilibrium of objects. So what is the meaning of equilibrium? The meaning of equilibrium is, all of you listen to me carefully. When net force acting on the object, when the net force acting on the object is zero. When net force acting on the object is zero, okay, so then we say that object is in equilibrium. Okay, so when we say that object is in equilibrium, stability is different from equilibrium. Stability వేరు, equilibrium వేరు. Stability లో కూడా there are different type of stabilities are there. So please follow me. Why are you doing all these things? When net force acting on the object is zero, then we can say that object is in equilibrium. Equilibrium means net force is zero. That's it. Okay. So whenever you say that equilibrium, then we say that net force is equal to zero. If net force is zero, we can say that object or system is in equilibrium. Simple. Net force zero means what? Net force means all forces acting on the object should cancel out. All forces which are acting on the object, it should cancel out. Okay. Whenever all forces are cancelling out, then net force we call it as zero. That means something like this. Suppose this is the object. Then F1 bar is one force, F2 bar is other force, and F3 bar, and then F4 bar. Okay. That is the four forces are acting. Then what the net force means? F1 bar plus F2 bar plus F3 bar and F4 bar. See, we are doing vector addition, not scalar addition. Don't add scalarly. Scalar addition we are at 10th class one again. Now we are doing completely vector addition. Many vectors ఉంటాయి, చాలా వరకు vectors ఉంటాయి, scalars కూడా ఉంటాయి, but you should keep an eye on this. Vector or scalar చూసుకోవాలి. So this will be the what? Net force. Okay, if it is equal to zero, then we say that equilibrium. If object is in equilibrium, then I can say that F1 bar plus F2 bar plus F3 bar plus F4 bar should be equal to zero. And it adjust all is zero. Resultant should goes to zero. You Pritam follow out now. You baad yaar physics. Pritam. Okay. Okay, so this is the meaning of equilibrium. Equilibrium means simple, very simple. So please don't make your brain heavy with all the other thinkings. Equilibrium means net force is zero. Whenever net force is zero, you can say that object is in equilibrium. Okay. So I can see so many videos are off. Which on your video? Otherwise, we'll remove from the class. Okay, all of you wrote down? Ready? Worksheet completed. Okay. But the problem is, okay, equilibrium means net force is 0. Ajay, wait. I'm explaining. That only I'm explaining. Okay. So equilibrium means we can say that net force is 0. But in the questions, they don't say that object is in equilibrium. They don't give object is in equilibrium. Then how to identify object is in equilibrium or not? No, that is. Okay, if net force is 0, can I say that m into acceleration will be 0? So here mass into acceleration I'm writing. M into a bar I'm writing means mass of the object is constant. I'm not talking about variable mass system. Variable mass we discuss later. Now we are discussing purely mass is constant. We are talking about objects, blocks, these things. So block mass or object mass is usually constant and a m constant and this thing. So that's why net force I can write down m into a bar. If mass is variable, then what is the net force I have to take? M into a bar plus dm by dt into v bar. So hope everybody remember that. Okay, in m into a bar and that means m is constant, mass is constant. So m into a bar 0 means a bar should be equal to 0. Because mass of the object is not equal to 0. మన object తీసుకున్నామంటే mass ఉంటుంది. So m won't be 0. So what will be 0? A bar will be 0. Okay. So when acceleration will be 0? So acceleration will be 0 under two conditions. When object is at rest. When object is at rest, then we can say that acceleration of the body is 0. What is the second condition? When object is moving. Object is moving with constant velocity. If velocity constant, then also acceleration is 0. So acceleration 0 will have two different situations. One is object is at rest or object is moving with constant velocity. Object rest line on the chute or object constant velocity and move out. Understood? Now tell me when object is in equilibrium. Can I say when object is at rest and or you can say or when object is at rest or object is moving with constant velocity, then we can say that object is in equilibrium. Okay, wrote down. If you wrote down, I'll tell you that step. So there are equilibrium లో ఆబ్జెక్ట్ ఈక్విలిబ్రియం లో ఉందా లేదా చెక్ చేయడానికి మనం ఏం చెక్ చేయాలి? అయితే రెస్ట్ లో ఉందా లేదా చూడాలి, లేదంటే కాన్స్టెంట్ వెలాసిటీ మూవ్ అవుతుందా లేదా చూడాలి. రెస్ట్ లో ఉంటే ఈక్విలిబ్రియం లో ఉన్నట్టు, కాన్స్టెంట్ వెలాసిటీ మూవ్ అయినా కూడా ఈక్విలిబ్రియం లో ఉన్నట్టే. నెట్ ఫోర్స్ విల్ బికమ్ ఆటోమేటిక్లీ 0. ఓకే, మనకి ఎక్కువ రెస్ట్ అడుగుతారు, కాన్స్టెంట్ వెలాసిటీ కూడా అడగొచ్చు. ఓకే, సో యూ షుడ్ బి కేర్ఫుల్. So equilibrium means we have to keep net force to 0. Okay, wrote down. Then we can make a one statement, that is what? When object is when object is at rest or moving with constant velocity, then we say that then object is said to be what? Said to be in equilibrium. Object is said to be in equilibrium, then we can say that object net force acting on the object is zero. Then we say that net force acting on the object is zero. Okay. So object equilibrium unda ledani ela chestunna, just we have to verify whether object is at rest or moving with constant velocity. So these are the triggering words. Then we can keep net force to zero. Net force zero means all forces should cancel out, or addition of all the forces will become zero. Okay, Rodana? So here, related to this, net force is equal to zero. Resultant force is zero, or resultant is zero. Okay. So actually, it has to be done in vectors, but so total vectors I didn't discuss at one time. So slowly we are learning all the things. So there is one theorem, it's called as Lami's theorem, which is useful for solving the questions of equilibrium. When they have given the question related to equilibrium, then you can use the Lami's theorem. So what is the Lami's theorem is? Let us say that there are three forces acting, F1, F2, or you can say F1 bar, F2 bar, and this is the F3 bar. These are the three vectors. Okay, with angles, let us say this is alpha, and this is beta, and this is gamma. These are the angle between the vectors. So already I told, whenever angle between vectors you are finding, the tails or heads are coincided. Vector ki either tail sign coincide undali or head sign coincide undali. Then only angle is defined. So I can say that alpha is the angle between the F3 and F2. Beta is the angle between the F1 and F3. And gamma is the angle between F1 and F2. Okay, if you want to write down. Alpha is angle between F2 bar and F3 bar. See once. Beta is the angle between F1 bar and F3 bar. Gamma is the angle between F1 bar and F2 bar. Okay. So then, if resultant of all the three vectors, see, Lami's theorem is for only three vectors. Lami's theorem is for only three vectors, not for four vectors. Okay. So it's actually, it will follow the triangle geometry. So some mathematical thing. With the triangle also we can do. If resultant of three vectors or three forces, I'm writing three forces because we are talking about Newton's laws of motion, but we can write down for three vectors also. So resultant of three vectors or three forces is zero. That means what? That means if they are acting on a particle, particle will be in equilibrium. Okay, that's what I'm discussing here. If resultant of three forces is zero, then we can write down some relation. What is that? F1 bar magnitude, first vector magnitude by sine angle between other two vectors. What is the logic here? What is the logic to write down? Vector magnitude by sine of angle between the other two vectors. See, F1 magnitude by sine of angle between F2 and F3. What is the angle between F2 and F3 is alpha. So sine alpha value. Nikhil, that is gamma is equal to F2 magnitude by sine of angle between F1 and F3 beta. F3 magnitude by sine of angle between F1 and F2, which is gamma. So this is the symbol for gamma. Understood? So this relation, if you want, you can use. Okay. In the questions, you can use this relation also. It all depends on how you are solving the question. Okay. So what is the Lami's theorem is saying that? Lami's theorem says that magnitude of one vector by sine of angle between the other two vectors. Magnitude of one vector by sine of angle between the other two vectors is constant or same. The ratio will be same. So F1 magnitude by sine alpha is equal to F2 magnitude by sine beta, F3 magnitude by sine gamma. Okay, no? So this Lami's theorem, whatever Lami's theorem we have done, this is useful in solving the questions of equilibrium. Why? Because this Lami's theorem is applicable, or this ratio, writing of this ratio is applicable when resultant is 0. See, I think all of you identified that part. When resultant is 0, then only we can write down this. Otherwise, you cannot write down. Resultant of three forces 0 means it's in equilibrium. Okay, completed. Very good. What about others? So what is sine alpha means? Alpha is angle. Alpha, beta, gamma are the angles. Sine of angle, sine alpha. Gautam, alpha, beta are the angles. Okay, completed. Very good. Alpha can be 30, 60, 120, 150, can be any angle. Alpha is the angle between F2 vector and F3 vector. F3 vector. F2 की F3 की मध्य में angle alpha. Okay. So this Lami's theorem also we can use in solving the questions. So let us solve some questions, examples related to equilibrium. Okay. The first example is, I think all of you finished, no? Anybody ready? So I think nobody is writing. Let us go with an example. Example for solving equilibrium. Suppose that there is a roof. Okay. An object of mass m is hung from the roof by two strings. There are two strings. Object is hanging to the strings. Object is hanging to the strings. Okay. So something like this. This is the horizontal. And one string is making an angle alpha, other string is making an angle beta. The block is hanging in the air. If block hangs in air, if block hangs in air, okay, means obviously block is at rest. Then find the tension forces acting on strings. So two strings lo tension forces enter. What is the tension force acting in the left string? What is the tension force acting in the right string? We want tension forces. Okay. You can please solve properly. I'm asking T1 and T2 values only, but you are saying answer in terms of T1. What is the tension value in the both the strings? Your answer should be in terms of mg, alpha and beta. I've given m. So mg ఉంటుంది. Alpha and beta lo మీకు answer ఇవ్వాలి. Alpha and beta are the angles. So this is what I told you. For this one, I have given the free body diagram. First, object is in the air, means object is at rest. When object is at rest, we can say that object is in equilibrium. When we say that object is in equilibrium, net force is 0. Okay, now block is at rest. So that is the idea. Block is at rest. That implies net force acting on the block is 0. That implies object is in equilibrium. Okay, net force will be 0. We can take the forces now. Identify the forces. Mg is the one force. In this string, let us say T1 is the tension acting on the block by the string. And this is the T2 is the tension acting on the block by the other string. So T1, T2 are the tensions. Now if I take block of mass M and Mg will act vertically downward. And this is the horizontal. Now this is the T1 at what angle? Alpha. And this is T2 at an angle beta. Okay. So total how many forces are acting? 3 forces are acting. And what we have to find out? We have to find out the T1 value, T2 value. But what is the resultant of all these 3 forces? Resultant of all these 3 forces will be 0. Resultant is 0 means all will cancel out each other. So that's why what I'm doing is I'm making into components. Okay, now T1 I'm making into components which I'm writing as T1 cos alpha. And other component is T1 sin alpha. So T1 cos alpha force will try to pull the body in rightward direction. T1 sin alpha will try to pull the body in upward direction. T1 I split into 2 components, T1 cos alpha and T1 sin alpha. Similarly, T2 also I split into 2 components, T2 cos beta and T2 sin beta. So making them all the force into components. Components along the horizontal, components along the vertical. Now see, object is not moving, all forces should cancel out. Am I right? Object should not move, all forces should cancel out. Now I can write down like this. Now I can write down all the forces after making components. See, for your understanding, I'm drawing again. Mg, rightward, what is the force acting? T1 cos alpha. Leftward, what is the force acting? T2 cos beta, right? And what is the total upward force acting? T1 sin alpha plus T2 sin beta. Am I right? T1 sin alpha plus T2 sin beta. Both you can add. Both are in the same direction. Both are acting in upward direction. Now T1, T2 are not there. Why? Because we made into components. T1 is 2 parts here. T2 got 2 parts here. That is the idea of components. Now object is not moving. Object is not moving means all will cancel out each other. That means what? That means T1 cos alpha should be equal to T2 cos beta. This is the one equation. T1 cos alpha, T2 cos beta rendu equal avar. Because both are opposite. Resultant 0 avarante equal and opposite undali kada. Equal and opposite unna anukondi. Resultant will be 0. A bar and minus A bar. Add cheste 0. magnitude equal undali, opposite direction undali. Similarly, upward force. Total upward force should be equal to total downward force. So I can write down T1 sin alpha plus T2 sin beta should be equal to mg. Okay. So now I got two equations and two unknowns. T1, T2 value find value. How to find out? From the first equation, I can write down T2 is equal to T1 cos alpha by cos beta. I can write down cos beta in position. So T1 cos alpha by cos beta is T2 value. Now keep the third equation in second equation. మనం T2 value second equation పెట్టాం అనుకోండి అప్పుడు ఏమవుతుంది T1 sin alpha plus T2 value T1 cos alpha by cos beta multiplied with sin beta is equal to mg. Okay, you can copy this, don't worry, just follow me. First listen to me and try to understand. See, T2 place lo T2 replace చేసా, then I'll get T1 value directly I can find out. So if I take T1 common చేసా అనుకోండి, then it is sin alpha cos beta plus cos alpha sin beta by cos beta is equal to mg. Just go for LCM. T1 common చేస్తే sin alpha plus cos alpha sin beta by cos beta ఉంటుంది. LCM చేస్తే sin alpha cos beta plus cos alpha sin beta by cos beta. Just solve yourself. T1 by just solve చేయండి. Then you can understand. Then T1 is multiplied with sin alpha cos beta plus cos alpha sin beta. So are you getting any idea? Sin of A plus B. What is the sin A plus B formula? Sin A cos B plus cos A sin B. This is the formula for sin of A plus B. So same format lo ఉంటుంది. Sin A cos B cos A sin B. కాకపోతే A and B plus alpha and beta ఉన్నాయి. Sin alpha cos beta plus cos alpha sin beta can be written as sin of alpha plus beta by cos beta is equal to mg. Okay, so then we can find out the T1 value. What's the T1 tension value? Mg cos beta. Now multiply the cos beta and obviously sin of alpha plus beta will divide it. So this is the T1 value. Okay. If we know the T1 value, we can go for T2 value also. T2 value you can find out because T2 is equal to T1 cos alpha by cos beta. T1 value rasa anukondi. Third equation of T1 value rasa anukondi, then we'll get the T2 value also. Okay. So I'm keeping from the first. Try to copy it. Understood? So there is one method. One method of solving equilibrium questions is what? Making the forces into components. Equal and opposite components change. Usually horizontal and vertical components. You make them horizontal and vertical components. So rightward force will cancel out with leftward force. All upward forces will cancel out with all downward forces. Okay? Na? So then you'll get some equations and you have to solve those equations. If you solve the equations, you can get the answer, desired answer. Completed? Okay, very good. Okay, completed. Very good. So once you know the T1, you can find out T2 value also. All of you find the T2 value. T2 value will find the end. Yeah, Adil, solve this now. Adil. Adil, are you solving? Okay. So here, hope everybody understanding the method of solving equilibriums. మీకు ఒక ఆబ్జెక్ట్ ఈక్విలిబ్రియం ఉందంటే ఏం చేయాలి? సాయిలీలా ఎస్ కరెక్ట్. సో దిస్ ఇస్ ద T2 వాల్యూ. ఒక ఆబ్జెక్ట్ ఈక్విలిబ్రియం ఉందంటే యూ హ్యావ్ టు ఐడెంటిఫై ఆల్ ద ఫోర్సెస్. సో హారిజాంటల్ అండ్ వర్టికల్ గా ఉన్న వాటిని వదిలేసి మిగతా వాటిని కాంపొనెంట్స్ చేయండి. Then you can cancel all leftward forces. Some of the leftward forces are equal to some of the rightward forces. Some of the upward forces are equal to some of the downward forces. And the upward downward forces equal undali. Rightward leftward force equal undali. Apna object automatically equilibrium lo untundi. Equilibrium ela identify cheyali? How to identify equilibrium? If object is at rest, then we can say that object is in equilibrium. If object is moving with constant velocity, then also we can say that net force acting on the object is zero. Okay, so what are the T2 values? T2 value is equal to T1 into cos alpha by cos beta. Now write down the whatever T1 value we got. What is the T1 value we got? Mg cos beta by sin of alpha plus beta multiplied with cos alpha by cos beta. Okay, then cos beta cancel out. I can write down mg cos alpha by sin of alpha plus beta. This is the T2 value. Tension acting in the second string. So tension acting on the right string, tension acting on the left string. Both we got. Nikhil, same question you're asking. Already you called me and you asked me a doubt. You called me, you asked me some doubt, I told also. If somebody is pulling you rightward with one force and leftward with the same force, then will you what is your displacement? Somebody is pulling towards right with one force and somebody pulling with zero. No, same thing only here only we are applying. You will answer and you will ask the doubt. I don't know what is the interlinking is not connected in your brain. You are saying the answer, na? Leftward and rightward same force are there, they're pulling the object. Then object is not moving, then they should be equal. They should cancel out. Cancel out means they should be equal. When they are equal and opposite, they will cancel out. For the same thing only, you call me up. You call me and you ask me the question. Okay. Done? Finished? Done? This is one way, one method of solving. Making the components and finding the resultant. Okay, here resultant is zero. We know resultant is zero. Resultant zero means all vectors should cancel out. So I'm repeating this maybe a fourth or fifth time. Resultant is 0 and vector should cancel out. What is the meaning of cancel out? They should be equal and opposite. And the opposite equal undali. T1 cos alpha, T2 cos beta opposite unnai. If they are equal, then they will cancel out. Then T1 cos alpha should be equal to T2 cos beta because object is in equilibrium. Net force has to be 0. That's why all upward forces should cancel out with the rightward forces. Okay. But without doing the components also, we can solve the question because here only 3 vectors or 3 forces are acting. Here how many forces are acting? 3 forces are acting, no? When 3 forces are acting, we can use the Lami's theorem, right? So I'm going to apply the Lami's theorem. See once. Okay, Lami's theorem is applicable when 3 forces are acting. So mg is acting downward, T1 is acting, and T2 is acting. And what are the angles they made with the horizontal? With the horizontal alpha, and this is beta. Now 3 forces are acting, and what is the net force? Resultant value is 0. 3 forces are acting, and resultant is 0. Then what I can write down? I can write down that mg is the force, T1 is the one force, and T2 is the other force. Now find the angles. Can I say this angle is 90 plus alpha? Because this is 90. Angle is అర్థం కావాలని వేరే diagram draw చేస్తాం. And this is 90. Am I right? Then what is the angle between these two vectors? 90 plus beta. So what is the remaining angle? What is this angle? What is this angle? I can say that this entire angle is 180. The total angle is 180. Then this angle I can write down 180 minus alpha plus beta. Am I right? Alpha, one side alpha is there, other side beta is there. So alpha plus beta is the angle. So what is the remaining angle? 180 minus alpha plus beta. So this angle will be 180 minus alpha plus beta. Okay. Understood? Now what is the Lami's theorem is saying that? See, don't remember the Lami's theorem like f1 by sin alpha is equal to f2 by sin beta is equal to f3 by sin gamma. That is only for understanding purpose. How to remember this Lami's theorem? Lami's theorem is vector magnitude, let us say mg. Vector magnitude by sine of angle between the other two vectors. So mg by sine of angle between T1 T2 you have to write down. What is the angle between T1 and T2? 180 minus alpha minus beta. 180 minus alpha plus beta. All of you okay with this? See, textbooks f1 by sin alpha is equal to f2 by sin beta is equal to f3 by sin gamma untundi. But manuala good particularly not to do mistakes, we have to remember like magnitude of the vector, one vector magnitude by sine of angle between the other two vectors. మీరు mg by రాశారు అనుకోండి, sine of angle between T1 T2 రాయాలి. So similarly T1 by sine of angle between mg and T2. Sine of angle between mg and T2 is 90 plus beta is equal to T2 by sine of angle between T1 and mg, which is 90 plus alpha. All of you understood? Then with one step you can solve. So this is the way to write down Lami's theorem. But Lami's theorem you can apply when 3 vectors are there. If more number of vectors are there, you cannot apply it. Okay, so I can write down this one as mg by sine of 180 minus theta, sine theta only. So sine of 180 minus alpha plus beta will become sine of alpha plus beta. T1 by sine of 90 plus theta. 90 plus theta means second quadrant. Sine of 90 plus theta will be positive. So sin 90 will become cos. So then this is cos beta. Then T2 by sin of 90 plus alpha will become cos alpha. So if I take these two terms, then what is the T1 value? T1 value I can write down mg cos beta by sin of alpha plus beta. If I take these two terms, mg by sin of alpha plus beta is equal to T2 by cos alpha. Then what the T2 value will become? Mg cos alpha by sin of alpha plus beta. See, you are getting the same values. Am I right? So both the methods you have to know. Why? Because Lami's theorem is only applicable for three forces. But if more than three forces are there, then you have to go with the component method. Okay, completed. Okay. Total is there, Nikhil. Entire solution is there on the screen. Lami's theorem. Lami's theorem heading is there. Final answer is there. Total solution is there on the screen. Okay, finished. Huh? So many people completed already. What about you, Nikhil? Finished? You can finish the. Okay. Now all of you try to solve this. So next question. So there is a block of mass n is tied horizontally. One string is horizontal, other string at an angle theta. Okay. So one string is horizontal, other string is at an angle theta with the vertical. Then find the tensions T1 and T2. Find the tensions acting in the strings. Okay, so no need to say that object is a test. Object is hung. Object is hung by two strings. So see how many forces are acting on the block. From that you can decide which method you want to follow. Components or landscape. Okay, so what are the force acting? So I'm drawing there only, directly on the diagram only I'm drawing. So mg is the one force acting vertically downward. It's a common force. Next, tensions will act along the string and away from the object. T1 will act horizontally, but T2 will act along the string and away from the object. T1, T2 should be away from the object. Okay. So now if I make a vertical, then what this angle should be? Theta. The angle will be theta. So then I can make components. T1 is horizontal, no need to make component. Mg is vertical, no need to make component. If any forces are horizontal and vertical, no need to make components. And what you have to make components which are not horizontal, not vertical. Then if I make components of T2, then I'll get T2 cos theta, and other one is what? T2 sin theta. So only 3 forces are acting. I think some people are trying with the Lami's theorem also. So that also you can do. So T2 cos theta is acting upward, T2 sin theta is acting downward. Okay. So then what I can write down? I can write down that mg is equal to T2 cos theta. Downward force is equal to vertical upward force. All forces should cancel out, no? That's it. T1 should be equal to rightward force is equal to leftward force. So T1 is equal to T2 sin theta. This is the second. So it's very easy to go. Take the first equation. If I take first equation, T2 cos theta is equal to mg. And what the T2 value is equal to? Mg by cos theta. This is the T2 value. Then how to find out the T1 value? Take the second equation. T1 is equal to T2 sin theta, and T2 value is mg by cos theta into sin theta, then mg tan theta. So T1 value is mg tan theta, T2 value is mg by cos theta, which is you can write down if you want mg secant theta also. Or else you can use the Lami's theorem. No choice. The vector is making angle theta with a line, then cos component will be there along that line. The other line will be sin component. Nikhil, you forgot the components. Verify the notebook once. The line along which it makes an angle theta, cos component should be there along that line. Now it is making theta with the vertical line, then cos component should be along the vertical. It should not be sin. And moreover, I'm teaching from the almost last 15 years, and around 6-7 years I read physics. So my journey with the physics is around 20 years. Okay, that means in the components I don't do mistake even in my sleep also. And that many times I have done. Something like you don't write your name wrong, no? మీ పేరు మీకు తప్పు రాయదు కదా ఎందుకు ప్రతిరోజు రాస్తారు కాబట్టి remember like that. In similar way, so imagine how many times I have done the components. In 1 year itself only I'll do more than maybe 5,000 times. So A line అయితే యాంగిల్ చేస్తుందో ఆ లైన్ లో cos కాంపోనెంట్ ఉంటుంది, పర్పెండిక్యులర్ లైన్ లో sin కాంపోనెంట్ ఉంటుంది. ఓకే, సో ఎనీబడీ ట్రైడ్ విత్ Lami's theorem? దీని Lami's theorem తో ట్రై చేశారు ఎవరైనా? If you are doing with the Lami's theorem, I think all of you have to know these things. Sin of 90 plus theta is cos theta. So trigonometry relations are good. Sin of 90 minus theta also cos theta. Sine of 180 minus theta is sin theta, but sine of 180 plus theta will be minus sin theta. Okay. Usually 180 plus theta you don't get in Lamy's theorem. You get less than 181. Angle between the vectors is less than 180. So all of you try to remember these trigonometric relations. So maybe useful when you are solving the Lamy's theorem. Lamy's theorem we use out. Anyone tried with the Lamy's theorem? Okay. Finally, you tried with Lamy's theorem. Huh? Okay, good. Okay, so I'm drawing the forces now. This is, I think, T1 we have taken, yes. And this is mg. Okay, and T2 is some other angle. At what angle? At an angle theta with the vertical. These are the three forces. Then what are the force acting? I mean, angle between the vectors. This angle is 90. Angle between mg and T1 is 90. What is the angle between mg and T2? mg and T2 will be 180 minus theta. Okay, what is the angle between these two? Angle between these two is 90 plus theta. The total angle you have to get 360. 360 should be the total angle. Okay. Now, what is the Lamy's theorem is saying that? Lamy's theorem is saying that vector magnitude by sine of angle between other two vectors. Mg by angle between T1 T2. What is the T1 T2 is 90 plus theta. Okay, is equal to T1 by sine of angle between Mg and T2. You have to write down. T1 by sine of angle between Mg and T2, other two vectors, which is 180 minus theta, is equal to T2 by sine of angle between obviously Mg and T1, which is 90. Okay, that's why I given all this things. Sine of 90 plus theta, sine of 90 minus theta, sine of 180 minus theta. Okay, so I've given all these values. Will be useful in solving the Lamy's theorem. Mg by sine of 90 plus theta, cos theta. T1 by sine of 180 minus theta, sin theta. And T2 by sine of 90 is nothing but 1. Okay, na? So if I take mg by cos theta is equal to T1 by sin theta relation, then T1 is equal to mg sin theta by cos theta, which is mg tan theta. This is the T1 value. Now these two are equal. So mg by cos theta is equal to T2. Directly you get the value of T2 is equal to mg by cos theta. So whichever thing is comfortable to you, you try with them, but you have to learn both the methods. And you get the Lamy's theorem only for 3 vectors. Whereas resultant we can apply for any number of vectors. Resultant of vectors we can apply cheyochu. That's why everybody has to learn the vector component method. Component sharing of this formula. So what is the Bipc question, Nikhil? Momentum of a particle is varying with the time. P is equal to 2 plus 3d square. The force acting on the particle at time is equal to 3 seconds will be. Am I right? What happened, Nikhil? See, momentum has given what? Momentum has given 2 plus 3d square. What the force is equal to? Change in momentum by change in time only, dp by dt. Total second law. This derivative. Then d by dt of p value. 2 plus 3d square. 2 derivative is 0. 3 into t square derivative is 2t. Then what the force value will get? Force value is equal to 60 Newton. But at what time they're asking the force? At time of 3 seconds. At time is equal to 3 seconds. What's the force value? 6 into 3, 18 Newton. And we discussed now Newton's second law is that only. Force is nothing but rate of change of motion. Even third question of formula కూడా ఉంది. F bar is equal to dp bar by dt. Third question I have given that also. Okay. Okay, finished? So all of you revise this equilibrium concept, and along with that, what is that? Drawing the free body diagram also. Okay. Free body diagram ni equilibrium concept in divide cheyandi, and tomorrow we discuss some other models. Some other questions also. Okay. So bye everyone. We'll meet tomorrow. All of you wrote down? Huh? Anybody writing? Anyone writing? Finished? Okay. Okay. Completed. Yes. So bye everyone.